Welcome to Beyond the Known Physics. I'm your guide to the frontiers of science, where we explore the questions that push past the textbook and into the unknown. Today, we're confronting a scenario that sounds like Hollywood disaster fiction, but is grounded in real data, real measurements, and real concern from the scientific community. Since 1845, we've been tracking something disturbing. Earth's magnetic field has lost nearly 10% of its strength. And in one region, the South Atlantic, it's weakened by more than 30%. Satellites passing through this area routinely experience electronic failures. Something is changing deep inside our planet. The question is, where is this leading? And what happens if the field collapses entirely? To understand what we stand to lose, we first need to see what we can't see. This is Earth's magnetosphere, an invisible force field generated 3,000 kilometers beneath our feet in the planet's core. Deep inside Earth, there's a solid iron inner core, about the size of the moon and heated to several thousand degrees Fahrenheit. Surrounding it is a liquid outer core of molten iron and nickel. This liquid metal is constantly churning, driven by heat from the inner core and the planet's rotation. And moving liquid metal generates electric currents. Those electric currents create magnetic fields. It's called the dynamo. This process has been running for at least 3.5 billion years. It creates a magnetic field that stretches far into space, deflecting charged particles from the sun, the solar wind, around our planet like water around a boulder in a stream. Without this shield, the solar wind would strip away our atmosphere. Mars is the proof. The red planet once had a magnetic field, but it died more than 4 billion years ago. Since then, the solar wind has been slowly eroding its atmosphere, turning a world that might have been Earth-like into the cold, dry desert we see today. So when we ask what happens if Earth's magnetic field collapses, we're really asking, do we become Mars? Here's the unsettling part. The collapse may have already begun. Since German mathematician Carl Friedrich Gauss began tracking Earth's magnetic field in 1845, we've recorded a steady decline. Over the past 180 years, the field has weakened by 9 to 10%. At this rate, some early projections suggested the field could vanish entirely in 1,500 to 2,000 years. But the weakening isn't uniform. There's one region where it's far worse. It's called the South Atlantic Anomaly, a vast area where the magnetic field is 3 times weaker than at the poles. Here, the field strength has dropped by more than 30% compared to other regions. For satellites in low Earth orbit, passing through the South Atlantic Anomaly is like flying through a shooting gallery. High-energy particles from space that would normally be deflected instead penetrate the spacecraft, causing electronic failures and disrupting instruments. In a cruel irony, even satellites designed to study Earth's magnetic field have been crippled by this very region. The anomaly is growing, weakening further, and drifting westward. Scientists have turned to paleomagnetism, the study of magnetic signatures locked in ancient rocks, to understand what this means. When lava cools, tiny magnetic minerals align with Earth's field at that moment, freezing a snapshot of the planet's magnetic state. By studying these rocks, we can reconstruct the field's behavior over millions of years. And what they've found is both reassuring and terrifying. About 40,000 years ago, something extraordinary happened. Earth's magnetic field didn't just weaken, it almost completely collapsed. Scientists call it the laschamps excursion. The field dropped to just 6% of its normal strength. The poles wandered, temporarily reversing for about 500 years before snapping back. This event was reconstructed with remarkable precision using two sources, sediment cores from the Black Sea, and the rings of an ancient quarry tree preserved in a New Zealand swamp. With the shield down, cosmic radiation flooded Earth. The skies would have blazed with auroras, not just at the poles, but across the entire planet. The increased radiation triggered atmospheric changes, ozone depletion, and shifts in global weather patterns. Some researchers believe this event coincides with the extinction of Australia's megafauna, changes in human migration patterns, and even the decline of the Neanderthals. The environmental stress of a collapsed magnetic field may have reshaped life on Earth. But the laschamps event wasn't unique. Go back 550 million years, and you'll find another near collapse. For about 15 million years, Earth's field was a fraction of its normal strength. Then something happened that saved our planet. The solid inner core began to form. As it grew, it re-energized the convection in the outer core, regenerating the magnetic field. Without that event, Earth might have followed Mars into desolation. The planet would be much drier and very different than the planet today, says geophysicist John Tarduno. The field came back, but the question haunting scientists today is, will it come back next time? Here's what's different now. When the field collapsed 42,000 years ago, the biggest concern was increased cancer risk from cosmic radiation. Today, we have something to lose that our ancestors couldn't imagine, a civilization built on electronics. The South Atlantic Anomaly isn't just a scientific curiosity. It's a preview. Every satellite that passes through it experiences what a weakened magnetic field does to technology. Cosmic rays are high-energy particles from supernovae and other cosmic sources. Normally, our magnetic field deflects most of them. But as the field weakens, more get through. They don't just affect satellites, they can corrupt data on the ground, cause errors in financial trading systems, and even trigger false signals in aircraft navigation. Then there's the sun itself. In 1859, the Carrington event, a massive solar flare, sent telegraph systems on Earth sparking and failing. That was with a strong magnetic field. Today, a similar storm could collapse power grids across continents, leaving billions without electricity for months. The U.S. government has estimated that a severe geomagnetic storm could lead to a 90% population loss within a year, not from the radiation itself, but from the cascading collapse of infrastructure. No power means no water treatment, no fuel pumps, no refrigeration, no communication. Society as we know it would unravel. Professor Andrew Roberts from the Australian National University warns that a magnetic field reversal could cause trillions of dollars in damage. When the field weakens by 90% during a reversal, our vulnerability to solar radiation spikes. And the poles are already moving. The North Magnetic Pole is currently drifting from Canada toward Siberia at 25 to 37 miles per year, up from just 6 miles per year historically. Something is changing in the core. Here is the honest answer scientists give when asked if the field will collapse. We don't know. Jeremy Bloxham of Harvard notes that while the field is declining, the chances of a full reversal are low. Reversals are a rare event, he says. John Tarduno agrees this could simply be an excursion, a temporary lull that will recover. Chinese Academy of Sciences researcher Rong Zhaojian puts it plainly. I am optimistic and do not believe it will continue to decay at this rate. Earth's history has seen many significant decays, but they all eventually recovered. The truth is, we can't predict the magnetic field because we can't see the core. The deepest we've ever drilled is about 12 kilometers. The core is 3,000 kilometers down. Everything we know comes from indirect measurements, seismic waves, magnetic observations, and computer models. Einstein himself called this one of the great unsolved problems of physics. More than a century later, it remains unsolved. Researchers are trying to recreate the dynamo effect using liquid sodium and other conductive materials. But scaling up from a lab experiment to the Earth's core is like building a sandcastle to understand a mountain. Even the South Atlantic Anomaly remains mysterious. Is it a precursor to reversal? A sign of a growing reverse flux patch in the core? Or just normal fluctuation? Scientists can't say for certain. So what does the future hold? If the field continues to weaken, even without a full reversal, we face a century of increasing vulnerability. Scientists like Nicholas Dalvini from the European Center for Geosciences warn the decrease in geomagnetic field is much more important and dramatic than the reversal. It is very important to understand if the present field will decay to zero in the next century, because we will have to prepare. Preparation is already happening. The International Association of Geomagnetism and Agronomy releases updated global magnetic models every 5 years. China's Zhang'an-1 and Macau Science-1 satellites monitor the field from orbit. The European Space Agency's Swarm constellation provides unprecedented data on core dynamics. Through initiatives like China's collaboration with Brazil, ground stations are being installed across the South Atlantic region to monitor the anomaly in real time. The story of Earth's magnetic field isn't a countdown to disaster. It's a call to understand our planet better, to build resilient systems, and to appreciate the invisible shield that has protected life for billions of years. So what happens if Earth's magnetic field collapses? The answer is, we don't know for certain. But we do know it's happened before. We do know life survived. And we do know that understanding this invisible shield is one of the great scientific challenges of our time. Here at Beyond the Known Physics, we believe the unknown isn't something to fear. It's something to explore. The questions that don't have easy answers are exactly the ones worth asking. If you want to join us on that journey, if you want to push beyond the textbook and explore the frontiers of science, hit that subscribe button and ring the bell. We're here every week to question, to learn, and to wonder together. This is Beyond the Known Physics. Stay curious.